Comparing fractions. Well, again, this is like decimals, where if I showed you zero point 0.4 and then I showed you zero point 0.5 and I said, which one's bigger? You would say, well, zero point 0.5 is going to be bigger than zero point 0.4. It's the same with these fractions. Now, when we look at two pieces of 3 and two pieces of 5, and I say which one's bigger, there's always something you can do, which is, why don't you just divide? Take 2 and divide it by 3 and show the decimal. Because remember, this decimal is the same, it's equivalent to what you're seeing as a fraction. So 2 divided by 3 is 0.6 or 66.66666. Remember that number? And 2 divided by 5 is 0.4. So really, when you look at 2/3 and you compare it to 2/5, if I wanted to show the decimal, I could do that and say, well, I easily can tell 60.66666 is bigger than 0.4. So I could say 2/3 is bigger than 5 or 2/5. This is very common to do. This is normally how I start students when comparing fractions, because a lot of times people have trouble seeing size in the beginning. For instance, if I look at the next one and say, let's look at 9 of 10 and then 9 of 12, you'll notice that these numerators are the same. But think about it. It takes 10 pieces to be complete over here. On this side, it takes 12 pieces to be complete. The one on the left is only one piece away from being complete. This other one is 3 pieces away from being complete. Let's divide them. 9 divided by 10 is 0.9. 9 divided by 12 is, let me just do it on the calculator to make sure. 0.75. So now I can easily see, well, yeah, 9 of 10 is big. It's one piece away. It's very close to being 1 or whole, where 9 of 12 is a little further away, but still a lot, 0.75. 9/10 is bigger than 9/12.